You take the absolute value of a number when you have a single number inside absolute value bars. All right, so I'm going to generically just write down the words always positive. That's not a good math formal definition at all, because technically absolute value is the distance from zero, the distance away from zero that a number is, and isn't a distance. If I measure from here to across the room, it's going to be a positive number. I'm never going to have a negative number. And it's because absolute value measures the distance away from zero. Okay. However, always positive helps you remember. All right. Now, absolute value bars, here's what they look like. Absolute value bars. So two up and down lines around a number. I'm just going to put something in there like that. Absolute value of -7. Now let's phrase this here. You must always have a single number. I'm kind of making that up. A single number inside the absolute value bars. I'm going to abbreviate before you take the absolute value. Oops. Before you take the absolute value. And then in parentheses, I'm going to say, make it positive. So that's me putting it into words as to what we're going to do with this. All right. You always have to have a single number, because not all your problems will have a single number. So you might have to do some arithmetic on the inside first. So I could see problems like this. I could have absolute value of a -1/2. All right. That is already the way they gave it to you. It's a single number on the inside. Okay. Or maybe they have absolute value of, say, -8 plus 4. All right, that is not a single number. So it's almost like order of operations. You got to work out the stuff on the inside first. This one, since it is a single number, I can just go, okay, absolute value of -1/2 is always positive. So answer is 1/2. Take the negative away because it's got to be positive, representing that distance away from zero, and you drop the bars. When you take the absolute value, you drop those bars. On this one, I have, let's do this wrong thing again. I have people say, oh, well, absolute value is always positive, so I'm going to make this positive. That's already positive, so then I'm going to get a 12. All right, that you can't do it like that, because why? This is not a single number in here. So you're going to work inside here first, do the math, just like you normally would. -8 plus 4 is a -4. Take the absolute value now because it's a single number, so answer is going to be 4. Okay, so yes, always positive kind of is a nice little shortcut way of thinking about what absolute value is, but you've got to remember you can only do that when there is a single number on the inside. All right, now the absolute value itself is always negative. That does not, or always positive, sorry. That does not mean, though, my final answer is always going to be negative, because it wouldn't have to be. All right, let's squeeze another one on right here. If there is a negative on the outside of the absolute value bars, and then maybe say a -8.1. I can put fractions in there, I can put decimals in there, I can put math problems inside there. This part right here, ignoring the negative in front, this is always going to be positive. It's a single number, I'm going to make it positive. But there's a negative out in front. And if you want to think of it as an actual number out there, there's an imaginary -1 that's being multiplied by that absolute value. So this negative stays out here. I turn this part positive, 8.1, -1. If I think of the -1 times 8.1, it's going to give me a -8.1. So see, the overall answer is negative. But when I ignored the negative in front and I just took the absolute value here, it really was positive. If I ignore that, it is positive. This comes straight down. So the negative comes straight down. Okay, we good there? Absolute value across the board is a relatively simple concept, maybe.